Welcome! Today we'll learn how to expand the function a to the x into an infinite series using the Maclaurin series. Let's start by writing our function. We want to expand f of x equals a to the x. The key to solving this is to rewrite this function in terms of e. We can rewrite a to the x as e to the x times natural log of a. This is a key property of exponentials that will help us use the Maclaurin series. Now, let's recall the Maclaurin series for e to the u. The Maclaurin series states that e to the u equals the sum from n equals 0 to infinity of u to the n divided by n factorial. To use this series for our function, we substitute u equals x times natural log of a. This gives us a to the x equals the sum from n equals 0 to infinity of x times natural log of a to the n divided by n factorial. Let's expand the series to see the first few terms more clearly. When we write out the terms, we get 1 plus x times natural log of a plus x times natural log of a squared over 2 factorial plus x times natural log of a cubed over 3 factorial, and so on. Let's visualize how this series approximates the function a to the x. Here's the graph of a to the x when it equals 2. The red curve shows the actual function, and the blue curves show the approximations using different numbers of terms. As we can see, adding more terms makes our approximation more accurate, especially near x equals 0. This is one of the key properties of Maclaurin series. They're most accurate near the point of expansion, which in this case is 0.